Okay, ladies and gentlemen, this is probably one of the hardest lectures you're going to have, which is organic chemistry, because naming organic compounds when you're first introduced to it can be very difficult. There's a lot of rules to remember, and it's one of those things that requires practice, 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 and for variety, more practice. So organic chemistry is always important because it deals with carbon chemistry, and all organics are carbon. Carbon's a small atom and it forms single, double, and triple bonds, and it is intermediate in electronegativity, which means that it forms strong covalent bonds with other carbons, hydrogens, oxygens, nitrogens, sulfurs, and some metals. So what's so important about carbon chemistry? Well, greater than 7, 10, or even possibly 30 million organic compounds, depending on which source you look at, can be made. There are 1.5 million inorganic compounds, for example, so there's quite a bit more in organics. Organics also form lubricants, cosmetics, fragrances, pigments, dyes, inks, adhesives, explosives, detergents, surfactants, emulsifiers, coolants, photographic agents, forensic chemicals, plastics, drugs, and it is the base chemistry of life. Remember that carbon makes 4 bonds to form a stable octet, and so it can make all of those bonds and therefore be much more powerful. When we take a look at organic compounds, these are the general categories: aldehydes, alcohols, ketones, ethers, acids, esters, amides, nitriles, amines, hydrocarbons, and halocarbons, and so there's quite a bit in there. We're going to mostly focus on hydrocarbons, alcohols, ethers, esters, and amines, but there will be a little bit of aldehydes. So the first one, and this is a hydrocarbon, is called the alkanes. Alkanes always have the formula of CnH2n plus 2. So in other words, whatever the subscript after the carbon, you find out how many hydrogens it is, because it's just carbon and hydrogen, thus the term hydrocarbon, N2n plus 2. So for example, methane is CH4, because the N would be 1. So 2 times 1 plus 2 is 4. So methane is the simplest one. C2H6, for example, would be ethane or ethane, depending on how you pronounce it. These prefixes will help you throughout. So meth, eth, prop, bute, pent, hex, hept, oct, non, and dec. So it's only methane, ethylene, or meth, eth, prop, and bute that are different from the standard Latin and Greek prefixes. All have ane at the end, and they all follow this pattern. Some of the properties of alkanes are shown here on this table, and you can see that as the number of carbons goes up, the boiling point goes up. As the number of carbons goes up, it's a different density at room temperature. So you can see that all the way through butane, it's a gas at room temperature, and these are very common propellants and accelerants and fuels that we burn. Think of propane tanks, butane tanks. Butane is what we use in lighters, for example, the liquid formula lighters. And you can see that the molecular formula follows that CnH2n plus 2 formula. Now there is a naming convention called IUPAC, and I'm not going to go into what it stands for because it doesn't really matter, but for alkanes there's very simple rules. With ANE means that all carbon-carbon bonds are single bonds. Okay, and you can see that here on this molecular formula, the structural formula. So all alkanes are carbon-carbon single bonds. The pent for this example means that there's 5 main carbons, because what you do is you count the longest chain. Okay, so the longest chain in this is 5 carbons, and they're numbered starting closest to the branch point. So you can see that we have this one group coming off of carbon number 2, so we start numbering it closest to carbon number 2. So 1, 2, 3, 4, 5 from left to right. The single CH3 coming off of carbon 2 is called a methyl group. You simply take the prefix for the number of carbons, so like methane, and you add an YL to the name. So methyl. So this one is 2-methylpentane. And it's 2-methylpentane. And you name that for the carbon that the group comes off of. So 2, and then the carbon group is methyl, and then pentane is the number of longest chain carbons. So let's take a look at this one. This is a saturated 6-carbon long chain with a methyl group. It's attached to the 3rd carbon. Remember, you always count the longest carbon chain, and you always number the carbons closest to the branch point. So this is 3-methylhexane. And again, this takes a lot of practice, so you need to make sure that you are doing that. Let's look at a little bit more complicated one. This one has 2 methyl groups coming off of the 2nd carbon. And you can see that it's a 4-carbon chain. Okay, so that means it's a butane, because 4-carbon is butane. So each addition to the carbon chain has its own number. The prefix di would indicate that there's 2 methyl groups added to the same carbon. So this is 2,2-dimethylbutane, because there's a methyl group going off the 2, and then a second methyl group coming off the 2. So it's 2,2-dimethylbutane. Let's look at one with something different added on. You can see here we've got a bromine and a chlorine stuck on it. So the carbon chain is again numbered from the end closest to the first additional group. So the first additional group is that chlorine, because it's sticking off the end. It's off of carbon number 1. The additional groups are then named in alphabetical order, irrespective of their position number. Okay, I'm going to say that again. The additional groups are then named in alphabetical order, irrespective, which means it doesn't matter, of the position number. So this would be 3-bromo, 1-chlorobutane. And you would write it 3-bromo-1-chlorobutane. You have to put those dashes in there because when you are writing these out on your Moodle quizzes, for example, if you don't spell it correctly or you don't put the dashes where they're supposed to or the commas, you will get it wrong. And there's not much I can do about that because you have to know how to name them accurately. And it's hugely important. So let's take a look. You've got alkanes and the alkyl group that is similar to the alkane. So for example, methane, when it's an alkyl group, in other words an add-on group, it's a methyl. Ethane, when it's an alkyl group, is an ethyl. Propane is a propyl, butane is a butyl. Alkenes are unsaturated hydrocarbons, which means that they contain at least one carbon-to-carbon double bond. Alkene means a double bond, alkane means all singles, so they're saturated. All alkenes end in -ene, and they follow the CnH2n rule. The simplest is going to be ethylene, which is C2H4. Now, one of the things that you need to know for alkenes, you'll see that this is 1-butene on the left-hand side. Why did I put a 1 in there? Because that's where the double bond is. There's no additional groups, but the double bond has to be numbered and named. So it is 1-butene. However, excuse me, however, the one on the right has 2 double bonds, so you have to name the carbons that they're on. So this is 1,4-pentadiene, okay, di meaning there's 2 of them. Penta means a 5-carbon chain. Okay, so 1,4-pentadiene, but you've also got that methyl group sticking off of carbon 3. So it's 3-methyl 1,4-pentadiene. Once you can kind of envision these in your head, when you read the ingredients labels on like a shampoo bottle, it gets a lot more interesting. Alkynes are hydrocarbons that contain one or more carbon-to-carbon triple bonds, and it's indicated with this little structural shorthand on the right. Alkynes always follow the CnH2n-2 formula, and they all have the -ine or YNE ending. The simplest is acetylene, okay, and that's C2H2. Alcohols always have an OH or hydroxyl group on them. So you can always recognize it's always an alcohol if you see the OH. Okay, so when you take a look at this, all of the alcohols have that OH group, and you're going to replace the E on the end of the word with an OL. So CH3OH is methanol, and it's the simplest, and this is pictured here on the right, on the very top. Alcohols are classified as primary, secondary, or tertiary depending on the number of carbon atoms bonded to the carbon bearing the OH group. So if you take a look, it goes primary, secondary, and tertiary alcohols from left to right on the little structural formulas at the bottom. When you name alcohols, it gets pretty interesting. So the first one on the upper left, we're going to go top row and then bottom row from left to right. So the top row is CH3OH. That's the simplest one. One carbon, so it's meth, so it's methanol. The second one, you can see, has two carbons. Or I'm sorry, the second one has three carbons. So this is propanol. The upper right one has two carbons, so that's ethanol, and that's typically drinking alcohol, is ethanol. Methanol is wood alcohol, and in the 1920s during Prohibition they actually tried to drink that. A lot of people went blind and a lot of people died from it, so don't drink that. But ethanol is the common byproduct of yeast fermentation, and that's the one that people drink, and it's also the one that helps, bread taste the way it does, and so on and so forth. Okay, so let's take a look at the bottom left one. So it's got three carbons, because every time the little structure bends, that's a carbon everywhere it bends. So it's got three carbons, so you know it's a propanol, but you have to identify where the hydroxide group is attached. So this is 2-propanol. The one on the right is a 4-carbon chain, because that's the longest chain, and you see that the hydroxide group is off at the very bottom, so that's on carbon number 1, and that you've got a 2-carbon chain attached at carbon number 2. So this is 2-ethyl 1-butanol, because the 1-butanol means where the hydroxide is added on, and then the ethyl is sticking off of carbon 2. In ethers, they have an ether group, which means that they have an O bonded in between carbons. Okay, so that's really simply all it is. It's a carbon bonded to an oxygen, bonded to another carbon. The simplest is dimethyl ether, which is on this slide. Okay, because that's CH3OCH3. Pretty simple. Ethers are soluble in water because they're polar, and ethers are also extremely flammable and often cause flash fires. You name these by putting the alkyl groups in alphabetical order followed by the word ether. So in other words, we got 2 dimethyls, so that's the 2 alkyl groups, and then ether, so it's dimethyl ether. Both aldehyde and ketones contain a carbonyl group. A carbonyl group or carbonyl group, depending on how you want to pronounce it, is a carbon double bonded to an oxygen. And you can see that here. The difference is that aldehydes have a hydrogen on the end, and ketones have 2 carbon-containing groups on both sides of the carbonyl group. Okay, so you can see that the aldehydes are on the left, ketones are on the right, because the ketones have to have 2 carbon groups, and that's the R stands for replacement, so that could be any carbon chain, and it's bonded on either side of that carbon double bonded to oxygen. Whereas the aldehydes always has a carbon double bonded to an oxygen and then bonded to a hydrogen. So aldehydes are named by changing the E on the end to an al ending. And ketones are named by changing the E to the ending to the -one ending. Okay? So the first one on the left-hand side on the top is ethanal. So 2 carbons, the replacement in the, well, I'm looking at the bottom left, sorry, not the replacement group. So this is ethanal because it's a 2 carbon. You have to have a minimum of 2 because you got to have that carbon double bonded to an oxygen. So you have a 2 carbon compound, and that's, it would be ethane, but because it's an aldehyde, it's ethanal. And the second one over here on the right-hand side, it's a 3 carbon containing molecule, so that's a prop, and so that's propanone. Finally, carboxylic acids. Carboxylic acids contain a carbon double bonded to an O, and the carbon is also bonded to an OH group on that same carbon. So you can see that in the model up at the top on the left-hand side. So when you have a carboxylic acid, you change the E to the N to an oic acid. Okay? Oic acid, OIC acid. So the simplest is going to be methanoic acid. The methanoic acid that you see here is on the left on the bottom. Methanoic acid is also known as formic acid, and that's the kind of acid that ants use in their venom. That's why it burns. The second one is a 2 carbon, so that's going to be ethanoic acid. And the third one is a 3 carbon, so that's propanoic acid. You're not going to get super deep into the carboxylic acids, but the alkanes, alkynes, and alkenes are going to be really heavily tested. So I highly recommend that you do a lot of practice with this material because it gets hard, it gets confusing. You're going to need a lot of practice. You're going to need to come to office hours. You're going to need to ask a lot of questions. So make sure that you are practicing with this material. Do not do it last minute because it will harm you fundamentally in your ability to do organic chem, at least at this introductory level. Okay, this is the second to last, and we're going to go on into nuclear chemistry at the next one. So I hope you have a great day.